Hello, and welcome to another episode of Around the Verse, our weekly look at Star Citizen's ongoing development. I'm Sandy Gardner.
And I'm Chris Roberts.
On today's show, we'll be visiting various moons and planets to show you how our procedural planet tech works.
Yes, but before we go exploring, let's head to our UK office for their latest studio update.
Hi everyone, and welcome back to the UK for our Wilmslow and Derby studio update. Our focus over the last month has been on getting 3.0 to everyone as soon as possible, as well as continuing our ongoing work for S42. For 3.0, we've been closing down the remaining features, and much of the team is moving on to bug fixing, polish, and optimization tasks. So let's start with what's been happening on our technical sprints this month. On the programming side, we've been helping with the Cockpit experience sprint with the goal of making the feeling of sitting in your ship much more dynamic. Some of this is incorporating psychological effects such as blackout and red out into the actor status system. So it's all controlled by one system that can influence things such as players' breathing and stamina. This sprint is also improving the G-force animations, the player hit reactions, and the ship gets a dynamic impulse. Close combat is coming along very nicely. We've been working on some great knife-based takedowns and unarmed takedowns, as well as working with design and animation to make it all look and feel extremely satisfying. One of the less visible but fundamental underlying pieces of technology is the new actor status system, or Actor 2.0, and we've nearly completed converting all the old player and actor code over to the new system. Whereas previous setup just inferred actor states from other variables, we now have a much cleaner interface for serializing between the server and all the clients. All told, it makes writing new player features much more straightforward and makes the code much more reliable. We've also been working on incorporating the brand new patching system into our internal copy build 3 tool that was developed over in Frankfurt and Austin. Now it's past QA's approval, we start doing a limited rollout to the dev team to carry on fleshing out any issues with it. So far it's looking pretty good, and the people using it are really appreciating the reduced time it now takes to grab the latest build. Moving on to the graphics team, the new render detection system has been a key focus this month. One major issue of this tech has been the hologram system, which will be used for mission briefings, comms calls, mobiGlas, and many other situations. The render detection system will be used for all our new user interfaces, and we're also aiming to use this for live rendering of video comms calls from other players. Our exposure control system had an upgrade to deal with the enormous contrast of lighting in space. The system now takes light from your peripheral vision into account, and so should no longer overly brighten the screen when looking into space when you are near bright objects. The graphics team have also added a host of new features to the GPU particle system, such as lighting, turbulence, and anti-aliasing. That will be used as many cool new effects in 3.0. The concept team has firstly been focusing on ship weapons. We have worked on the Amon and Reese laser cannons S1 to S6 and the Klaus and Werner laser repeater S1 to S6, along with some associated VFX. On a smaller scale, but just as important, we've taken the Gemini manufacturer and created a slick-looking heavy machine gun with the iconic cooling system as seen on other Gemini guns. This month, we took on our 6th member of the concept team, who's looking at areas of Stanton system and more specifically Orison, while also supporting additional needs on Squadron 42 locations. As ever, we continue to search this universe far and wide for more talented artists. The environment art team has been building some exciting prototypes for procedural cities. This will allow us to create vast cities and landing zones and planet surfaces for the Stanton system and beyond. Work continues to flesh out texture of space and to provide a greater palette for the artist to make space travel interesting and at times support the narrative in both the persistent universe and Squadron 42. One specific element is our new space dust shader, allowing us to add large volumes of space dust to the Stanton system for the 3.0 release. Yellow's asteroid belt has also been improved, which once again makes use of the new shader type. All the major outpost archetypes have been finished. This includes dressing for different corporate and independent companies for various functions such as mining, hydroponics, habitation, and storage. It also includes some additional unique varieties such as emergency shelters, abandoned outposts, and gang-owned outposts too. All outpost doors and airlocks have been switched to the Door 2.0 system, meaning that they can interact with different rooms, power systems, oxygen, overrides, and hazards. Outpost clusters and additional exterior elements have been finalized. This includes outposts, landing pads, paths, power modules, water collectors, weather stations, relay stations, and exterior lighting. The branding prototype has been completed, so now outposts are represented by several different corporate companies, as well as independents and gangs. Planet surface integration is ongoing. Sand, dust, and frost materials have been finalized to help blend the outposts into the moons. Decals have been used to add an extra layer of dirt buildup and have also helped to blend in the exterior landing pads and props. The team have finished all pre-polish and optimization work on the exterior truck stop pieces and have moved on to finish the interior. The main hub is currently being worked on, based off concepts from art direction, and additional pieces have been made to add more of a truck stop character. Props and lighting are currently placeholder. The side shops and corridors have had a first pass on them. The Platinum Base shop is having its own building set made for it, so it looks more distinctive, and an admin office has been created so players drop off packages relating to missions. Finally, an observation room has been blocked out facing the landing pads, so players can watch the comings and goings of other players' ships from the interior of the station. Also, admin offices have been added to other Stanton locations such as Port Olisar and Grimhex. All the 3.0 locations have been updated with a new door and airlocks 2.0 system, and 2 new shops have been added to Grimhex. One is an independent ship's part trader, and another, Technotic, is an old electronics store that may house a mysterious character. On the UI front, work has been cracking along on the new Moby-Glass UI and all the other various new apps that will become available for 3.0. Last month, we successfully integrated the Moby-Glass and kiosk UIs using the new render to texture tech, and the visual result proved promising of further achieving the look that the team is after. In addition, we've been working with the VFX team to couple particle effects and lighting to help ground the UI projection within the game world environment. As part of this, we've been working to drive the second multidisciplinary sprint for the Star Map app, the goals of which are to implement the remaining functional requirements for the 3.0 release, as well as improve upon the general visual fidelity and user experience from previous iterations. This involves focused collaboration between art, VFX, audio, and engineering teams to help bring together a refined experience. We've also wrapped up work on implementing the basic functional requirements for the new Mission Manager app, allowing players to view information on available missions, as well as allow players the ability to accept, track, and abandon missions which have been accepted, as well as view a log of the previous missions which have been completed or attempted. Along with the work on the Item 2.0 ship conversion, we have started to implement the new pilot multifunctional displays, which refines the UI of previous iterations and adds new information as well as capabilities in managing your ship systems. We've also been helping with the recent doors and airlock sprint, where we helped to design and implement new status displays for the various airlocks throughout the system, which also utilize the new render to texture tech. The audio team has been involved in lots of different sprints and pipelines as usual this month. Weapon audio completed work on weapons such as the railgun, and having made steady progress on derelict ship audio and the interior ship audio for the Javelin. The team is also helping to finish up the actor status system so that the breathing from the player works alongside dialogue more intelligently, and a new outlaw music logic set was completed which will be reflective of the player's reputation system. Also, various locations for the 3.0 release have been revised and improved in terms of environmental and ambient sound, with members of the audio team even attending a character-based sound recording at Shepperton Studios. The animation team has been working closely with gameplay programming to continue development to the takedown kill mechanics. Weapon improvements and tweaking continues across the board for the upcoming 3.0 release. The jump mechanic is receiving some love to get a more flexible system to cope with various environments and gravity states. Moby-Glass has been moved from a look pose to an aim pose to allow increased functionality. We've also added in some extra animation to the enter and exit states to make it feel more connected to the player. AA combat assets continue to be exported and tested where possible in engine. We've also been continuing the export of cinematic scenes for design to implement in engine. The Derby studio has been busy on 3.0 mission givers. Both are coming along very nicely, and it's exciting to see life being added to the PU. Facial animation is still being produced by the team for S42 and future PU releases. The mocap guys set up the system for a quick shoot in the new office space. It was great to see such a quick turnaround of the data from shoot to in-game in a matter of days. There was another quick audio headcam shoot earlier in the week for some last-minute pickups for 3.0. The facial data is already edited and in production. As always, the ship team has been up to a lot this past month. Work on the derelicts is coming to a close for this phase. We have the Starfarer, Caterpillar, Constellation, and Freelancer ready to be used in various gameplay missions, both in space and planetary locations. The underlying tools to allow placement correctly on planets so that the ship components and wreckage all conform nicely has now also been implemented. This will allow for some well-crafted artist-driven derelict sites while maintaining the ability to use those sites on various types of terrain. Coinciding with concluding of the derelicts is a bug-fixing pass sorting out any issues such as collision or minor art tweaks. On the Hull C, the team has finalised geometry on the folding section and blocked-in materials. We are currently in the process of finishing the mechanical rig and making sure that all operates smoothly without any collisions. The front of the interior has now had an initial lighting pass and has been continually tweaked to help areas gel together. The rear of the interior has been blocked out and is now getting a modelling pass on a room-by-room basis. Work on the Eclipse is well underway with focus currently on the cockpit. Extensive work has been done on the dashboard, collaborating with other departments to make sure that the layout is appealing and the monitors are legible. With a new Item 2.0 push, it's important to place buttons and switches within the player's arm's reach to create further interactivity and immersion. The landing gears have been fleshed out, and work on the wings has begun starting from the outside, working towards the center of the ship. Work on the reclaimer is almost complete, with only 3 rooms left to go through final art. This month we've wrapped up final art on the cargo room as well as the main lift. In both cases, we tried to maximize the space to allow for easier transportation of cargo. A huge amount of effort has gone into making the cockpit functional in a tight area. We've implemented retractable screens which fold around the player when seated. And we were hugely excited to see the tractor beam seats transition from concept to final art, and we're really looking forward to seeing people using them in the verse. And the team has also been busy working on the bridge area and the bridge lift, which provides access to the lower deck. Well, that's our update for the month. I hope you've all enjoyed seeing what the team here in the UK, as well as the rest of the world, has been up to. As always, thanks for all your support in allowing us to make this great universe. And of course, thanks to all our subscribers who provide for us to be able to do these updates for the community. And take care, and I'll see you all in the verse.
All the UI is looking pretty cool and coming along nicely. Searching the star map from your Mobi will not only be helpful, but also is a great way to show the vast size of these systems.
Yeah, no, they're pretty huge, as you can see from the sort of star map demo. And also the Mobi Glass refactors coming along really nicely. There's going to be a whole bunch of functionality and apps that you'll get in 3.0 that you didn't have before, so that's cool, as well as the various finishing touches we're putting in on the environments, like the outposts and the derelicts, which are also looking awesome, as you can see from the episode. So I'm actually looking forward to the point where all you guys can adventure around in that. It's going to be pretty cool.
Another thing to get excited about for 3.0 is the introduction of our planet tech. Designing this system came with numerous challenges of its own, including how to procedurally place objects like rocks and flora in a way that looks natural.
Yeah, so to learn how the team handled these obstacles and many more, we put together an in-depth look at our procedural planet technology. So let's check it out.
Hello, I'm Marco Corbetta. I'm Senior Technical Director at Foundry 42 Frankfurt. We're going to talk about planets today. So what we're going to look at here today is the planet tech and some of the features we're going to include into our first 3.0 release. The planet tech is exactly the same tech which we have been using for moons, planets, Delamar, the Delamar planetoid, Lasky, and so on. Each planet is unique. It has its own gravity, ecosystems, objects, weather, and atmosphere. If you look at the footage here, the progress we made since we started working on this, you can see the planet from space, and you can smoothly fly from planet to space without any cutscenes or interruptions. The major challenge here is that you can land anywhere seamlessly on the planet. And basically, the only way to do this is to generate the planet's surface as you're approaching it. The terrain is getting generated, recursively subdivided. Objects are procedurally scattered on the surface as they are becoming visible, as well as particles, ground details, and so on. When you are on the surface, you're able to see objects like space stations, moons, and so on, orbiting around the planet in space.
For our entering the atmosphere and getting closer to a planet, in order to make sure that it looks good on all levels, from high up to the ground, we have different artist-driven input on each level. So on a global scale, we have our color map that defines the colors of the planet. And then when you get closer, we have our ecosystems that is defining our features. These all fade into each other and become one thing. So the closer you get, the more it fades towards the final result on the ground.
We can also transition from a solar system down to a planet's surface. Here we're showing the scale we're dealing with. You can see the different level of zooming from a solar system down to the different moons and planets. It's very challenging to deal with generating all these different type of environments at all these different scales. We have a fixed pool of geometry shared for all planets and a fixed pool of memory used for texture streaming. Since you can land anywhere, as mentioned before, the only solution is to procedurally generate on demand the planet's surface. The geometry is generated on the fly, and textures are procedurally combined at runtime, blending many layers. This allows seamless transition from space to planet. The source data used for generation is very small. For example, on these moons, we are using only about 5 unique ecosystems for each planet. Each ecosystem has different properties, and they are all combined with other layers and noise combinations to generate a large amount of variations all over the planet's surface. Another interesting thing is that we are using only 1K resolution for all textures created by our environment artists. These textures are used for planets generation. So we have developed an efficient generation and blending to combine all these textures layers together and still getting good results when you're close to the surface.
The biggest challenge, I think, with what we've been working on lately is the scattering of all these objects on the terrain. From the last update that we made, we have done a lot of progress on the terrain and the textures. We could render all these big mountains and oceans and all this type of stuff. But in the end, the planets were still empty. There was no content, there were no objects, no rocks, no trees and all that. We had a very basic system, but that didn't really work for what we wanted to achieve. So most of the R&D time that we had in the last couple of months went into this object scattering system. The difficulty with the object scattering is to get a natural look. When you make a level for a game, and you can place your rocks anywhere you like, or your trees, and you can compose the scene where the player comes in, and you have this nice vista and these background assets and all this type of stuff. But we can't really do this on the procedural level. We cannot really place all the assets by hand, so we need a way that kind of automates this for us. And of course, you want this to look as natural as possible. So you want to have a little bit of control, but also want to have most of the work you want it to be taken care of by an algorithm. We developed a system where you can kind of define what assets you have. Say you want to do a forest, you need some trees, you need some leaves, you probably want some grass on the ground, and then you can define certain object groups and say, okay, I want to have a tree in there. And then you can define a certain logic that around the tree you have leaves. You can define particle effects so that the leaves fall down. You also can add audio in there, so you have like wind blowing through the tree. Basically, these object groups or object presets are like packages which then are assigned onto the terrain on specific areas where you want these trees to grow, basically. And then the scattering is done in an automatic way. But it follows a certain logic, so you can define like a natural harmony, so it's not just completely random or in a grid pattern that would be very noticeable to the human eye. You get to define how the assets are arranged. So you have like a huge rock, you want some smaller rocks around them, and then some very tiny rocks around those again. So you kind of create an aesthetic. So it's not just, okay, I have this big rock and the small rock and the tiny rock, and then it just scatters it over kilometers of terrain. We had this in the beginning, and then we added more and more parameters to change the visuals. And then of course you have values to tweak random scaling, random rotation, alignment to the terrain, and all this type of stuff. As an art team, we produce all the content that forms our final planet, and that contains like the ecosystems that define our terrain shapes. It includes the materials that define the look of the ground when you are walking around in first person. We built the rocks and the assets and the shrubs and the plants. We basically build all these components, and it's remixed in our procedural planet tech. Besides reusing and remixing our textures and materials, we also built them in a smart way. When we build a material for our rocks, for example, we also use the same material in our ground textures to define how the small rocks on the ground look. In order to do this, we use Substance Designer, which really allows us to break down all our texturing components into separate modules, which we can then plug in and remix and change the settings on the fly. So this really allows us to speed up our texture creation process and allows us to quickly knock out different variations of different colors of sand, different amount of rocks on the ground. And we have a lot of ground to cover on our planet, so we try to cover a lot of space, multiple planets. So we need to make sure that however we work, we do it in a smart way. Whenever we try to define a material palette for one of our planets or locations, what we actually do is we build our set of materials and we apply them in an asset suite where we can toggle the time of day, have a view of what does it look like at a steep sun angle, what does it look like at a 12 o'clock sun. And that way, when we combine all these elements, we know that at least at the baseline, everything looks good. When feeding these materials into our planets, there's various elements that influence how the final material looks on the planet. Procedurally, these different materials will be mixed, other elements will come in. It will sample colors from the global definition of how the colors look on the planet. So wherever you go on the planet, the result of the ground is never the same. What we try to do when we build an asset library for the procedural system is to not, for example, define the final surface material. So what we try to do is make sure that it's reusable as well. We can take the same rock type or same rock shape and then reapply a different material on there. And then use it in a neighboring moon or system. This is making sure that we can put more in our memory because we're using the same base elements, but it also makes covering this large area faster.
Another big challenge that we had with the object scattering, or how we build our frames in the game and make these environments look very good, was that we don't really have any background assets. So in traditional games, you always have your foreground and your midground, and then you also have background assets that are basically making up the scenery, where you normally never go there. For example, you're in your jungle, and in the back there's a big volcano, but you can never really go there. It looks really epic, but it's mostly just a background asset. In Star Citizen, there is no such thing as a background. Everything that you see on the screen, you can go to. And this also then goes into our workflow, how we make the assets. Sometimes the things in other games that you see in the background is just a painting. It always looks the same, and if you go up close, you just see there's a wall in front of your face, which never happens because the player space is restricted. But in Star Citizen, there is no restriction for the player space. For smaller rocks, this is fine because you only see them when you come really close to them. But if you have large cliffs in the back, you want to see them from far away. You see them when you're close up, and you want to have them nice and detailed. And you want to have a nice transition when you come from outer space and these large objects are coming up. Every asset has to be made that it works first person, that it works from a little distance, that it works far out in the background, and it also should work from outer space.
Another major challenge is dealing with online games and procedural generation, because the generation needs to be deterministic on all machines. So we need to do a bunch of operations on CPU side to make sure it all works on the dedicated server as well. Usually dedicated servers don't have a graphics card. So currently all terrain generation is done on CPU, and most of the visual textures blending is done on GPU on the client. Generation results are cached in the fixed geometry pool mentioned before, and the generation is distributed over all available meshing cores. So the generation is very efficient and is scaling with the number of available cores. The generation results are exactly the same on client and server, so there is no need to transmit any information to replicate the environment. Here we're watching a video recorded by our QA of 4 players playing together and landing on a planet. You can see the seamless transition of all of them landing on the same planet surface.
What makes working with our planet tech so different is the scale. When you would work on an FPS level, for example, you would, even if it's a very large map, you would cover 4 kilometers. You don't have to worry about what happens outside of the playable boundaries. What we try to do in Star Citizen is basically cover all those elements. So you come in from a very far distance, fly close to the surface, you step out of your ship and you walk around and look at the rocks and the ground and the details. You have to make sure you cover all these different ranges. Which takes some getting used to. It's an interesting system to work with for sure, and on the one hand you lose the opportunity to handcraft. every single meter around you. At the same time, you're generating like large-scale environments, and the procedural system allows us to set up these rules where the way the stuff that's placed, you get these situations where like, wow, I couldn't have like made this if I tried to.
You never really know what's going to happen, how the objects are arranged. So every now and then you come to a corner of the moon, which you have never seen before. I mean, on one hand, you don't have the hand placed in control, but you also don't really want this because it spent years on just one planet. But yeah, the nice thing is that every now and then you come to a certain corner of the planet or the moon, and you're just surprised by how the objects are arranged. And it just works out beautifully. Also with the sunlight, you never know how the sunlight is because the planets, you never know what time it is, or you can't just say, okay, I want this in a sunset. So every now and then you have these moments where everything comes together and it just works out beautifully, and you have this nice, scenic, huge environment right in front of you.
We define the rules. We define our shapes that we would like to see, but it isn't until everything comes together and you actually fly around and just land and just look around like, wow, all these elements that our team built right now, it's all put together, and this is the world that we made.
To end this presentation, we're going to show you a procedural planet visual effects breakdown, showing how the different elements are combined to compose the final image. Thanks for watching.
As Pascal said, in Star Citizen, there's no such thing as a background asset. If you see it, you can go to it.
Yeah, and also what makes the game so challenging to build. Every asset must be crafted so it looks good, not only from a distance, but also from right in front of your eyes. And there aren't many games that have those demands on them. And I think it's one of the things that makes Star Citizen so special.
Yes, it is. And that's it for today's episode. We'd like to thank all of our subscribers whose support makes shows like ATV, Bug Smashers, Lore Makers, Citizen of the Stars, and Happy Hour possible.
Yeah, and thanks to our backers, we can't be building this incredible game without you.
We could not. And until next week, we will see you
around the verse. you for watching. So if you want to keep up with the latest and greatest in Star Citizen and Squadron 42's development, please follow us on our social media channels. See you soon.